let's say that this subset is, let's say this subset is, I don't know, let's say I'm calling it y actually. Okay? So y is some subset of x. Now, what I want to do is that if you pick, so here's one thing, so you have open sets inside x, and then you have a y inside x, then obviously these open sets and y are some of these open sets and y will intersect with each other actually. And what is their intersection? For example, this is one intersection, this is another intersection, this is another intersection, this is another intersection, and so on and so forth. Okay? You have these intersections. Okay? I mean, I'm not obviously making white all of the intersections, but I have done some intersections. Now, this collection of intersections of y with the open sets of x, okay? These intersections are not necessarily open in x. Is there any okay? X may be open. Okay? Even, and keep in view that I'm not even assuming that y is an open set. So y is some subset of x, and these, pink border lines are the sets are basically what you call open sets in x. But when you draw this set y, these intersections are not necessarily open sets in x. But what I can do is that I can take these intersections and put them in a set, and I can say that collection is going to be a new topology. Okay? So that topology is not going to be a topology on S, but that is going to be a topology on Y. And that topology is, we call it a subspace topology. Okay? So what do you mean by that? So you have, this set and open sets in this set, and then you take a random arbitrary subset of, x, and then you take all these intersections and then put all of these intersections in a set. That intersection, this collection of intersections is basically a topology, but on Y actually. Okay, so these are open sets, but with respect to the topology on Y, not on topology on X. And that's what I just want to put now in words actually. This is what I'm gonna put in words. So let's say that you have a topological space. Okay, so you have a topological space, and let's say that I take some subset of x. Okay, and then I am creating a new topology. So let's say I'm denoting it by tau y. It's like making sure that you understand that like this is a topology on y, but this is a collection, okay, of intersection of y's with the open sets of in x. Okay, that is that you take u's from tau and intersects them with y, and then collect this intersection of the intersections, collection of intersections, and this collection of intersections is also a topology. And this topology is called a subspace topology. Okay? Subspace topology. Like you must have seen this notion of subspaces in, say, vector spaces actually. And you have a vector space, but you have a tiny little set sitting inside vector space, and then that tiny little set that is sitting inside vector space also have a vector space structure actually. So you call it subspace. Now we are doing precisely something like similar. You have a set, an open set on Y. Okay? So in other words, the open sets in the subspace topology looks like this. Okay? But these are open sets in subspace topology. Keep in view that these are not necessarily open sets in X. Until you know something else about y. So obviously we're not just gonna take this thing, we say we're not gonna take it for granted. Actually, we need to show that this is a routine topology. Okay. So why do you think that this should be a topology? So if I say I have to show that y empty set should be in
tau.
क्यों होना चाहिए? Again, look at the definition. So what does this definition is telling? That this is the intersection of all open sets, okay, from tau with y. So we know some interesting sets, open sets in tau. Which kind?
Empty set.
Okay. Now since phi is in tau, so there must be y intersection empty set in tau y. Okay? This must be inside that. Then, what is this quantity? What is this object? That's empty set. If you intersect something with empty set, it should be an empty set. This shows that. And what should be the other property?
X.
Why?
It's a topology on y.
Yes,
We
sir.
need to justify that y must be inside tau. So can you suggest or think of some set जिसे हम जो है लिख सकें इस शक्ल में. So as we have written the empty set as y intersection something, can we write
Y equal to
y as y intersection
X.
something's u? U.
X.
Or what is u actually?
X.
X.
U, Y.
Y should be x. So what will happen? Is it true?
Y subset of X.
Yes, sir. Y equal
Is
to
it true that y intersection x should be y?
yes, sir.
Yes, sir. Yes.
इसलिए because y is a subset of x. This is true because y is a subset of x. So if you take intersection of a set with its superset, you get smaller set as a result. And this shows that this guy is in tau. Alright? So I don't know. I'm just gonna do another property. Let's say that I just take let me just show that the third property, that arbitrary union of open sets is open in y. By the way, how does the arbitrary union would look like? कैसी दिखाई देगी arbitrary union यहाँ इस sense में?
इंटरसेक्शन की यूनियन होगी.
इंटरसेक्शन होगी. इंटरसेक्शन ही होगी ना. इंटरसेक्शन होगी.
इंटरसेक्शन की यूनियन बनेगी.
So consider क्या लिखूं? You got to tell why. So I need to take this kind of sets actually.
Yes.
So this is say an arbitrary collection of open sets inside tau. Okay. So consider this arbitrary collection. And then I need to show what? That the union of this arbitrary collection is also in tau.
Yes, sir.
So if I take the union of say this arbitrary collection, what I'm going to get? So what should be my next step?
Sir, जो U है वो open है tau में. यदि हम Y से intersection करेंगे तो फिर भी tau में tau Y में चला जाएगा.
This is what that we have to show at. ठीक है? But what is the ticket to go inside tau y? What is the ticket to go inside subspace topology?
Distributed property.
So, this thing, so anything that goes inside tau y should look like y. So it should be y intersect with something that is open in
Tau.
not y but
Tau.
tau actually are x. Okay? So this is something that we need to do. So in its current form it doesn't look like that. क्या करें? So this is union of the intersection set.
यूनियन ऑफ अल्फा इंटरसेक्शन वाई
कर सकते हैं इसको
So you
डिस्ट्रीब्यूट
can do what do you call the distributive law, okay? And you can say that this is same as y
वाई इंटरसेक्शन
intersection union of alpha
यू
u alpha. So this is something that should be verified. I mean, it looks like trivial, but you know. What is a concrete form of distributive law? How does the distributive law looks like now? So you have, say, I don't know, A union B intersected with A union C. So this should look like, you know, this is same as that A is intersecting with B union C. Okay. So in other words, what is common in this union is that what is common between this union and that's distributive law, and that's precisely what we are doing here. Because the union of the intersection is basically the intersection of like you can pull out this y and you know it's like y intersection. Okay, but this is something that needs to be verified. So you need to verify this. You don't have to take it for. अगर आपने distributive law prove किया है for generalized union and intersections, good. I mean नहीं किया तो this is a good exercise actually that you need to do that. You just don't have to. Now, do you think that this guy is in tau y?
Yes sir.
क्यों?
सर क्योंकि सर U में ओपन पड़े हैं ना टाउ, U टाउ में पड़े हैं तो ओपन होंगे नहीं, उनकी इंटरसेक्शन y से लेंगे तो ओपन जाएंगे, वो भी टाउ में।
सर यू ओपन है तो उनकी यूनियन भी ओपन होगी।
Yes, this is you got to be precise. That since these u alphas are open inside X, okay, I should say this. Y intersection u alpha where u alphas are open in X, they are from the topology on X, and then since you can write this expression in this manner, so this means that you have u alphas that are open in X. So their union is also open in X because tau is a topology, X is a topological space. So this means that since this object can be written in this manner, so Y intersection is something open. So this must be inside tau. Okay? So think about the intersection yourself. Third property. Okay? So see, I'm leaving the gaps for you to fill in actually. So I'm not writing a proper proof. So you know, when you are writing a proof, you need to write the details. Yes, and you know, just write it like me. You know, you have to write it in. Okay. By the way, what we have done with this. So by doing this, what we have done is that I took a topological space and I just took an arbitrary set. Okay, inside that topological space, and I turned that arbitrary set into a topological space actually. Okay, and you know you can have plenty of subsets of X, and each one of them can be turned into a topology of topological space. Okay, so this is like creating a new topology out of existing topology. So we last time we saw how कैसे वो cross product लेकर of two topologies you can create a third topology out of it. So that's another recipe for creating topology of it. I mean with the you know with the finite sets and simple examples of topology you can find subspace topology pretty easily. बहुत आसानी से कर सकते हैं. Okay, for example, if you take X to be ABC, okay, and give me a topology on X. So you set X and A and say AB. So that's a topology. Okay, that's a topology. Now if I take for example a subset of X, I don't know, let's say I take BC. The question is, what is the topology topology, subspace topology based on that. So what you can just do is just take this Y and intersect with each one of this open sets. ठीक है, इनमें से हर एक को इसके साथ intersect कर दें and then take that collection. That collection is going to be your tau Y. So what would be tau Y connect quickly? Empty Y and that's it.
B sir.
So that is going to be the Swinsky topology. Subspace is this is Swinsky topology. So this is the topological space. You can take some other set. You can take AC. Maybe you get a different topology and so on and so on. Okay. Alright. Now, what natural questions you can ask that? कौन से natural questions आप पूछ सकते It doesn't say anything about size. Does it ask for anything? यहाँ कुछ size नहीं अच्छा ये this is going to be a coarser than but ये भी जरूरी नहीं here's the one thing actually ये जरूरी नहीं है comparison भी because like here you have a different maybe you can make a comparison in this sense, for example. So we haven't assumed any structure on Y. So what if I assume, here's a remark. What if I assume that Y is open in X? Let's assume that Y is also open in X. It's not just subset, but it's open in X. Then what you can say about these sets? You.
ओपन से करेंगे तो ओपन इंटरसेक्शन आएगा
ओपन से करेंगे तो
सर बाय भी हमने assume किया
yes, so this is what we are saying. Now since Y is also open and U's are also open, then intersection is also open actually. So what does it mean? Now you can say that this is a coarser topology then, or maybe equal to who knows, maybe but it's a topology that is coarser than the TX actually, or the topology on X. ठीक है? ये हो सकता है कि ये, I mean if I take Y to be say just this open set A actually, and then I generate topology through it. So what are you gonna get? Empty set Y which is A and that's it. That's it. But okay, still there is going to be a trouble actually. So can you see the trouble? Still there is going to be a trouble. X कैसे आएगा इसमें? नहीं. So here's the thing. So if I take Y to be A, so intuitively things look very similar, but when you try to go into details, then Y is going to be what? There's going to be empty set and Y. But is this a subset of, okay, yes, this is a subset of this. Okay, so in that sense it's a coarser. Okay, it's a coarser. But for having a coarser topology, you have to be careful that you need to have topologies on the set X actually. ठीक है, comparison आप तब कर सकते हैं कि जब दोनों topologies जिनको आप consider कर रहे हैं वो दोनों subsets हों किसके? X के, ठीक है? So even though this looks like is a subset of tau X, I can't call it this is coarser than tau X actually. क्यों? Because this is not a topology on X. अगर ये topology on X होती तो फिर हम कहते कि this is coarser than X actually. Okay, so this is kind of subset of topology, but it's an independent topology. It's a different topology. So you got to be careful.
I have a question.
Sure. sure.
बट आपने कहा कि y एक ऐसा सेट है जो इसके अंदर लाई कर रहा है और ओपन सेट से उसकी हम जो
Intersection.
एक साथ इंटरसेक्शन ले रहे हैं, अगर y भी ओपन है आपने अभी कहा और ये u सेट भी ओपन है तो ये तो पूरा हो जाएगा ना अंदर से।
जरूरी नहीं, बस सिर्फ इतना है. So here's the thing. इतना है कि each one of this part, since y is itself open, so this part is also open, this part is open, so each of the path is open. It doesn't mean that कि ये पूरे x को cover कर रहे हैं.
x को नहीं पूरे y को।
Why? I mean देखिए टोपोलॉजी के लिए y सेट को कवर करना जरूरी नहीं है. This is another thing that therefore I have left some gaps actually. ठीक है. So think about it. Like is this topology is covering everything here? यहाँ जो elements हैं. No. या ये क्या ये टोपोलॉजी जो है वो कवर कर रही है in y? I mean, so the open sets are. I mean, if you include y, then yes, you know they are covering. But ये जो दूसरे open sets हैं, which are strictly subsets of, say for example, y, वो cover नहीं कर रहे y. ठीक है? So you don't have to. So this is what the trouble with the picture is actually. Sometimes picture tells you something that is not there. So we need to carefully draw the pictures. ठीक है? तो यहाँ पर you saw that I haven't splitted the entire x into the open sets. I have split it into the parts. ठीक है? And I did the same with the y. ठीक है? X का तो खुद भी एक open set है. But you can't necessarily cover with these parts the entire x. ठीक है? हाँ, if you are taking bases, I mean if you are taking the basis of a topology, then you know there are going to be open sets that are going to cover everything. ठीक है? Anyway, so this is probably our next question actually. That what if I know a basis for this parent topology, can I get a basis for this baby topology? So कैसे करेंगे?
डिफाइनाइट इंटरसेक्शन मालूम करते तो y के
किसके सबसेट्स उठाएंगे और किससे इंटरसेक्शन लेंगे?
नहीं y सबसे ले आने
हाँ,
तो उसकी फाइनाइट इंटरसेक्शन करें
किसके साथ?
उसके एलिमेंट्स
किसके साथ करेंगे? With
x के
किसके open sets? So I'm talking about basis. So here's you got to be precise actually. That's what I'm asking. You got to be precise. I can see that आपके दिमाग में जो है ना you like वो picture बन गई. You just have to say it out. So sometimes you don't find words to say it. So this is what that we have to learn. Again, no one is going to trust your words, the things that goes in your head actually. You got to put it on pen and paper and rigorously prove that. ठीक है? So here's the thing. So let's assume that that I have a calligraphic B that is a collection of B's. So B is open in X. Okay. And it's a basis for X. So in other words, these are the open sets that almost cover everything in, not almost, but covers everything in X. Okay. Now, can you give me a basis for Y using this? If I ask you, what is your guess for basis for Y? Come on, that's not difficult to. So this is basis for X. Okay. So I need basis of
y intersection b.
y intersection
y intersection b.
y intersection
y intersection b.
So the basis for Y should be.
y intersection b.
So you just need to do what? So see, यहाँ हम क्या कर रहे हैं? So you are taking the open sets and intersecting it Y, and you are getting this topology.
Yes sir.
Now, if you have a basis for X, then how can you find the basis for you know,
Open set of
y, so just take the open sets from here, like these basis sets, intersect them with y, okay? And this collection of you know y intersection b's, claim ये है is basis for okay, like we did in cross product actually. Think about it. So how did we found basically say the basis for product topology? So we said that okay, if you have a basis for x and a basis for y, just take the rectangles, you know, the cross product of basis element, that is going to create the basis for you know the product. So you just need to think naturally. ठीक है. So y is the basis for. So what should I proceed? What is the first thing that I need to do?
open set में
Is say so since this is the basis of y, so then we need to tell actually that every element in y is in this kind of some set.
Yes, sir.
This is what we have to think. So let's say that I am taking y from y. Okay, how can I find some open set that looks like this, in which it is guaranteed that there is y, this small y? क्या करूँ? ठीक है, that's a good start. So since y is a subset of x, so
there exists
there exists a basis for y.
सर अगर y
Then
सबसेट
y
x
also
तो y x में भी होगा.
X में भी होगा ना.
Good. So this means that y is inside x.
Yes.
So what?
सर हर एक्स के एलिमेंट के लिए बेसिस में होता है लाइक ओपन
सर
सेट
ये पता,
उसमें वो होता है
सर ये मुझे पता है, हर एक जो x हमारे पास है उसके लिए हम एक बेसिस ढूंढ सकते हैं.
Good, good, good. So see, proofs just follow this naturally, logic. Huh? Nothing, you know. So in other words, now since you got to write it, लिखना पड़ेगा. So since calligraphic B is a basis for x, so I can find a B inside this basis such that y is living inside that basis.
Yes, sir.
So what should be the next step?
वाई में भी हो और बी में भी है तो वो उनकी
इंटरसेक्शन में भी होगा सर.
Done. Done. This means you need to tell your reader actually, as y is inside y and y is inside b, so y is inside y intersection b. Now it's in good shape, so this is in my calligraphic one. So I'm done. It means that such sets cover entire y. Okay? Alright. What is the next thing that should do in the second problem? So we will take some two basis elements of this shape. Let's take y intersection b1 and y intersection b2.
intersection from
From by. Another should say consider. Doesn't make sense actually. So consider these two from by. Okay.
take x belongs to intersection
And the x is inside y intersection b1
इंटरसेक्शन
y intersection b2. Okay. So
y
tell me y intersection B3
Yes, sir.
that contains my x and contains the inside of it.
Yes.
That's what I have to show for basis. कहाँ से ढूंढूं वो मैं? B1 intersection B2 वो तो ओपन हो जाएगा इसमें, वो तो एक सबसेट हो जाएगा यहाँ. Which property?
सर इसको
सर,
प्रॉपर्टी
दोनों
लगा के
का-
एसोसिएट
और B1 में भी होगा
Associative
B2
property
में.
लगे. Yeah, even.
y कॉमन है.
Y
In
common.
other words, I can write this guy
Y intersection B1
y intersection
B1
intersection
B2.
which is equal to this. Okay, so x is in this and x is in this, so that is. So, what is the next thing?
X belong to Y, X belong to
So
B1
x is inside y
and
and x
X
is
Y belongs to
inside
B1 and
B1 intersection
B2.
So,
सर हमें पता है कि ये
सर B3 होगी इसमें सर
this is basis.
Yes, sir.
इसके लिए तो मुझे पता है कि this is basis. As calligraphic B is basis, so I can find B3 inside calligraphic B as that x is inside B3
B3 सबसे
and inside B1 intersection. Okay, so
अब सर
x belongs to y intersection B3
good. So x is inside Y
Y intersection
and
B3.
x is in also intersection B1 intersection B3. But is this enough? Sorry, B1 intersection
B1.
नहीं B
B3
B3 होगा ना, सही
Y
है.
intersection B3
Yes, sir.
and क्या हो?
this is dy
So X belong to Y, X belong to X.
ये Y में है चले. Okay, आगे.
उसके
इससे prove कैसे हो गया क्या? What precise statement you need to show? You need to show. So here's the thing. You need to show x is here, and you need to find a third element,
Yes, sir.
okay, which contains x and is subset of this.
X belong to B3.
So the only thing that now you have to think is that why this guy is a subset of this guy.
सर क्योंकि
सर
B3
B3
सबसे हो
सर B3
B3
सबसे
सबसे.
Three subset have B1 intersection B2 का, so I can say this is subset of y intersection B1 intersection B2,
yes
which is precisely equal to this. That's what you needed to prove. यही है ना? So what that you needed to prove. And now you have a recipe to create the basis for subset topology. Okay? And then we'll get more members, you will see that basically there are tons and tons of really geometric examples of all that. ठीक है? करेंगे. Lot more to come. Okay, we need to learn these bases. So what we have done so far, you take topology, you take a subset of it, you take the intersection of that subset with open sets, that's a topology, and if this set Y is itself a topology, okay, then every element here is open in X as well. And then another thing that we did is that that if you take if I do what? So if you take a basis of a topological space and then you can create, using that basis, you can create a basis for subspace. Okay? Here is the next interesting thing. Let's say I have two topological spaces, X and Y. So let me have X with tau X and Y with Y are the topological spaces. Okay? You can view, I'm not assuming that this is subspace of this. I'm saying that X and Y are two independent sets. Okay? And you have two topologies. Okay? In other words, X is this, and you take, say, a subset X in A, okay? And maybe, I don't know, Y looks like this, and I have another subset of this topological space Y. Okay? Then I know the product of X and Y is also a topological space.
Yes.
Then what naturally you can think? So if X and that X or Y key product is a topological space, then using A and B, can I create something? Another topological space, and that is going to be. So in other words, here's the thing. I know that X cross Y is a topological space,
Yes, sir.
and obviously A cross B
Is also
is going to be a subset of
F
this
cross
topological space. Okay. Then this cross product, okay, of two. Using these two cross products, I can create obviously a subspace topology as well.
Yeah.
Okay. Using these two, I can create a subspace. Then tau A cross B, which is going to be what? It is going to be the intersection of A cross B with the open sets here, U cross B. Okay, that's how it's going to look like. Where U and V, maybe
The
U
U
is
belong
open
X.
in X
V not
and
Y.
V is open in
Y.
Y. Okay, and that's a subspace topology on A cross B. So agreed? Are we happy with it?
Yes, sir.
Right. By the way, the current terminology हम use करते हैं, quite often use here that say if you have a set, a topological space, and then you consider a subspace topology of that, you know, the bigger topological space, we say that this subspace topology is, or this subspace or subset is inheriting a topology from its parent topology. Okay? It's kind of inheriting. So like this is inheriting a topology from X cross Y. Okay? There is, do you see something odd here? Subspace topology के जो open sets होते हैं वो कैसे दिखाई देते हैं? By the way, you can also write this in this manner. What would be an alternate way of writing this set?
X comma
A intersection U. A cross U.
intersection B cross B.
B cross.
So you can also write it in this manner. Anyway, so that's the subspace topology. We can have very interesting examples. Go ahead.
Intersection with Cartesian region.
सर A intersection
A intersection
A intersection U cross B
A intersection
U cross
cross
B
intersection.
intersection B.
सारे लोग जा रहे हैं. So I sum sometimes say things correctly, but I write silly things. So be always careful. Okay? One thing you got to learn in science is that trust no one. Okay? Unless someone gives you a rigorous proof and someone is telling you something with clarity. Okay? And you can question almost anything. Everybody. Okay? So let's do some examples. Let's do some examples. Okay? So let's do some non-trivial examples. So let's say, so the first example, so एक तो हमने वो देख लिया that you can take finite topology with a finite number of open sets, and how you can create the topology out of it. But here's another example. So let's say that X is let's say that I take this closed interval, okay, and obviously, so here's the thing. So on Y, can you tell me some topology?
Union of
Y पर कौन सी topology? For example, if you take X to be R actually,
Yes, sir.
so on R you have a standard topology, and Y is a subset of R, so it must have a standard topology on it actually. And how does the open sets looks like in this standard topology?
Close.
Interval.
Open, sir. Open interval.
Y is not second with
Open interval.
such open intervals. Okay. So it's not necessary that it should be open, because this can there is open set हो सकते हैं, so they could be this or the union of such open intervals. Okay. What are the open sets inside standard topology? What is the basis for a standard topology? So open intervals.
Yes, sir.
Okay, so this means that open sets inside R are either open intervals, or they are the union of open intervals. Actually, that's what we have to so it inherits a topology. Okay, so this Y. So example is that Y inherits topology. From X, in which the open sets looks like this actually, are the union of such elements. But here is another thing. So take Y to be an independent set actually. Okay, Y the है. Are you happy with this first example? सही है ना? ठीक है. Basically, Y intersection AB is going to be the collection of the open sets, which is going to create a basis for this topology. ठीक है, तो ये open sets भी हैं, but these are the fundamental open sets actually. ठीक है. Again and again I'm saying, standard topology में जो open sets होते हैं वो या तो interval होते हैं या फिर union of intervals होते हैं.
Yes, sir.
AIs and BIs. इस तरह की होती है. ठीक है. So in other words, then this open sets here are going to be either of this form or is going to be Y intersection. So when you take Y intersection union of AIs and BIs, how can I rewrite it? So I can rewrite this as, this is union of Y intersection.
Yeah.
So what does it mean? That in the standard topology on Y equal to 0, 1, the open sets are either like this, which is like Y intersection one open interval, or open sets are like this, which is Y intersection tons of open interval, which is same as union of Y intersection such open intervals. अंडरस्टैंड एक्चुअली पिछली चीजें रखेंगे ध्यान में तो फिर आगे भी समझ आएगी बात, ठीक है, बिकॉज एवरीथिंग इज कनेक्टेड विद एवरीथिंग एल्स। अच्छा, एंड देन आई ऑलवेज यू नो encourage you to think actually कि जितने भी हमने examples किए हैं ना different, ठीक है, so whatever notions जो भी हम कर रहे हैं पढ़ रहे हैं, आप उन notions को उन examples पर भी apply करते हैं, ठीक है, for example you know we learned what is the basis of topology, ठीक है, but we learned lots of examples of topologies like discrete topology. You can ask what is the basis of it. You learned what you call, for example, a cofinite topology. You can ask what is the basis of it. What is countable union topology? What is the basis of it? So whatever the topologies that you have learned, you can think naturally that what would be the basis for each of the examples, for example. Okay, so push them exercises के तौर पे दे सकता हूँ. And similarly the case is here. That I mean, you have learned a discrete topology, for example. You have learned cofinite topology. You have learned order topology. You have learned lots of examples. Now, what would be the meaning of, for example, having a subspace topology under order topology? Or what would be the meaning of having a subspace topology under, say, discrete topology or cofinite topology? Okay. So, notions को आपने ऐसा apply भी करना. So, there is one thing. By the way, if you think, missed one thing, I must say, okay? If you think that what would be y intersection AB, okay? So y is like this interval which starts from 0 and gets to 1, and where could be AB at? So you have this entire line. AB कहाँ हो सकता? So AB could be this, which do not intersect at all with y. So this means that 0 should be empty.
Everything.
Okay. In other words, this is going to be empty. I would say if A and B are not inside y. Not inside y. I mean, if they are not inside y, the open interval is not going to be. How about the other possibility could be that how about, so here's another, what could be other possibility?
They would be intersecting.
Intersectance क्या होगा? One is inside but the other is outside.
Yes, sir.
Then what would be the intersection?
0 to this.
This is going to be 0 to
B.
B. Okay. So if A is inside, A is
Not inside.
outside B, and so this is the
B
case
is
when
inside
B is
Y.
inside. How about the case when A is inside
B
B?
होगा 0
0 क्लोज होगा.
सही है सर.
Zero close. Zero.
सही है सर.
ये है ना intersection में नीचे.
0 क्लोज
So this is
मिनट
what
में आ रहा है
intersection
0.
जीरो ओपन होगा.
open होगा.
क्लोज होगा ना.
क्लोज होगा सर.
क्लोज होगा.
नहीं, zero क्यों close? Zero is included in y actually. Zero is included in y. ठीक है?
सही.
How about if you have A to B? So B is outside and then this the same intersection is
1 to B.
8 1.
A to 1. Okay? So if A is inside y and B is not inside y. ठीक है ना? A is inside y,
सही.
but B is not inside J. ठीक है?
Yes, sir.
What would be the last possibility?
दोनों
ठीक है? So in that case, the intersection is going to be and A and B are both inside Y. Now here is the interesting thing actually. Here is the interesting thing. R these open sets which are open in subspace topology are open here or are open here. Certainly empty set is open.
Yes, sir.
This kind of topology. This is open. But are these two इनमें से कौन सा open?
वो भी यूनियन है सर
अपर लिमिट है
यूनियन ऑफ ओपन और एक
वो कौन सा ऐसा सेट है जो कि इन ओपन सेट्स की शक्ल में नहीं लिख सकते? Can you write
सर वो
this as
एम्प्टी
the union of open intervals? Can you write this as the union of open intervals?
लिख सकते हैं ना इसको.
अगर नहीं लिख सकते, this is not open in. इसका मतलब है कि this is open in subspace topology, but not open in
ये
the
वाला
parent topology. बच्चे की अपनी शनाख्त भी. This is something that you have to. Is that this property? How about this one actually? Be necessarily open. नहीं है. इसमें this is obviously open in subspace topology. But not necessarily open in standard topology. You have to be careful. I mean, it's not necessary that and why this is happening. I mean, if you take y to be itself open, then just take y to be 0, 1, then everything is open. Okay. But if you are taking y to be this closed set, okay, closed interval, then some sets are open. All of these sets are open in subspace topology, but they are not necessarily open in
X.
standard topology or standard topology. This is something that we have to keep in view. ठीक है? Now the best way to आपको यहाँ से जो है like you have got kind of a sketch of the things that what I have done, but the best way is to learn is to read the book section पढ़े, ठीक है? तो वहाँ बड़ा अच्छा मुकस ने लिखा. I mean, are you reading? Yes. You write very well. एक चीज़ है, he writes things in words. He doesn't write more precisely, but he writes in such a way that you're okay. ठीक है. All right. कितने मिनट आते हैं? एक एग्जाम्पल फिर बात कर देते हैं उसके बारे में.
Yes, sir.
So here is an example. About X is R with a standard topology, and Y is this guy. 1, 0, union, singleton. One union. Now, obviously now you have to think that what would be the possible intersections between Y and AB. Maybe you can think yourself. इसी तरीके से you just have to think that what is the relationship between AB and Y. But you have to keep in view that now you have this additional 2 and 0 is not inside. ठीक है? A और B जो हैं
सर वो इंटरवल 0 to 1
oh, sorry, 0 to 1. 0 to 1. Yes, you're right. Okay. So these A's and B's are one of these could be 2 axes. So you have to think in this manner. So एक तीसरा example भी वो आप खुद कीजिएगा. So examples हैं जरूर कीजिएगा. So read them, they are readable.